So here we have a little complicated situation in which there is an I-beam, it's IPE 500, and there's another I-beam which is approaching it, it's an IPE 300, but this is not a perfect approach. It's approaching, it's both skewed and it's lifted, it's rotated. So it's coming at an angle. It's not a 90-degree. It's also raised from this point. It's also moved in the X direction. So it's coming in at an angle. And we want to create a manual connection because none of the macros, let's say, will do this, although there are macros in there which will make this connection. But let's say we don't have a macro and we want to do some manual detailing over here. So we want to create a fin plate sort of a connection over here, right? But it's going to be a pretty complicated connection if you can already see that. So let me look at it from the side. I just rotate the view a bit over there and look at it from the exact side. And so first of all, I'll need to pull back this beam a bit. I'm going to pull it back to about this level. So let me just do that. So if this is the end of the beam, so I can just give it an end offset of say 120 maybe. Yeah, that seems about right. I want to pull it back a certain distance, but I want a fin plate over here. And the fin plate, I want actually 4 bolts over here. So I want a bolt over here, a bolt over here, one more over here, and another one over here. And I want the fin plate to come like that into this web of the main, go around the bolts, and from this point, join to the bottom flange, go like that, and then connect to the top. This is my aim. This is the kind of fin plate I'm envisioning. But this fin plate, what we need to know about this fin plate is that this fin plate lies on the web of the secondary member. That's the primary constraint. It has to lie in the plane of the web of this secondary member, and then all the points of this plate will need to be on that web. So the best approach would, in this case, be to create a view on the web. That's going to make things easier for us. So to do that, I go to my view commands and I take my view by 3 points, which is the most general command for creating views. And I put my origin over here. I put my X direction over here. So I press the control button to select any point on the line. And then I put my Y direction once again by pressing the control button because I'm snapping to basically any point on the line. And when I do that, immediately a new view is created. And in this view, I can see that the secondary beam is perfectly aligned with this view, but the main beam now is looking weird. But we don't have to worry about that. So we are now in the plane of the web of this secondary beam. And what I want to do now immediately as a good habit, which I've mentioned before as well, I want to put the work plane in here so I know exactly where I am. I go to the edit menu and I go to the points menu. And the first thing I want is a point somewhere over here. It's about 60 millimeters from the top. This is where I'm envisioning my fin plate to be. So put a point over here, 60 millimeters. This is the top of the fin plate. So let's do that. So I create a extension point. Let me press the shift key and press the extension command. And let me enter minus 60 over here, right? And from the bottom, I can go towards the top with a minus 60 setting. So it's going to create a point which is 60 millimeters from the top. This is exactly what I want. Now, where do I want the bolts? I want the first bolt to be somewhere over here, the second bolt to be somewhere over here, the third one to be over here, and the fourth one to be here. So the interbolt distances in this direction are 40, 40, and another 40 to get to the edge of the fin plate. And the downward distances are 60, 60, and then another 60 to get to the bottom of the fin plate. So I'll create the 40, 40, 40 in this direction first. So for that, the best command I have is the parallel points command. I can press the shift key and I can enter something like 3 multiplied by 40 and then use these 2 points to create these 3 sets of parallel points, which are each at a distance of 40 from each other. So this is 40, 40, 40. And now I need another 3 points, 60 downwards. So for that, I go to my settings once more. I change my settings to 3x60. And what I basically do is I use these 2 points over here. So my bolt points will be, or this will be my first bolt point, this will be my second bolt point, this will be my third bolt point, this will be my fourth. This is where my bolts need to be, just so that I can see that later. My fin plate, on the other hand, will come along this line, will go down all the way to this point, and then it will join up with the bottom of the flange and the inside of the web and all that, and we'll discuss that. So let me go back to the other one, the other view, and we can see that we've created these points over here. Now, as we just discussed, the fin plate will be along the web over here, right? So what about so the fin plate will consist of how many points? If we just go to the side, if we can just look at it from the exact side, we know that the fin plate is going to start off somewhere over here. It's going to go like that. It's going to come down. So this is point number 1. And we don't have it yet. We don't know where this point is. It's going to start from there. It's going to go like that. We know this point. It's going to come down. We know this point as well. But then it's going to come to hit this point over here, and we don't know where that point is as well. And then it's going to go in and hit another point over here, and we don't know where that point is at this point. So we don't know this point. Let's call that point 1. We don't know. Point 2 we know. Point 3 we know. Point 4 we don't know. Point 5 we don't know. And this is point 1 again. So how do we create point 1? Now, if you think about it, point 1 is basically the intersection of, so let me just rotate this slightly. Point 1 is basically the intersection of the line along these points with the web of this main. Wherever this line hits the web of the main beam, that's where my first point is. So I have a command for that, if you remember. I can use my line plane intersection command, which is over here. This is line plane intersection command. And this one asks me for 5 points. So 3 points for a plane. So the first thing I do is define a plane. So I can say this is my plane. The origin is over here. The x-axis is this, and the y-axis is 1. So now I have defined my plane over there. And where is my line? I can say my line, I can just use any of one of these 2 points. And it has given me a new point. And this point now lies on the web of the main, and it is exactly along this line, wherever that may be. So I've got my first point ready at this point. But now I've got point 1, I've got point 2, I've got point 3, but I don't have point 4 and 5. Where are they? If you think about it, point 4 has to be, which point 4 is basically going to come and join along somewhere along this line, the bottom of the right side of the bottom flange. So if you think about it, once again, that point has to lie on the web of this, on the plane of the web of the secondary beam. So, and what about this, the 1, 2, 3, 4? What about the 5th point? The 5th point has to be along this line, but also on the plane of the web. So let me repeat that. The 4th point needs to be along this line, but also on the plane of the web of the secondary. And the 5th point needs to be along this line, but also on the web of the plane of the secondary. So once again, we can go to our plane points command, select a plane on the web of the secondary. So I can use these 3 points, for example, to select the web of the secondary. And now I can select my 2 lines. Line 1 and line 2. So we see immediately over here that the 2 points have been created. What did we do? We just chose the plane of this web of the secondary, and then showed these 2 lines, and wherever these 2 lines intersected that plane, we've got the points. So now basically we have the points ready. So all we need to know is just connect them. So we can go to our steel menu, go to the contour plate command, begin from point 1, point 2, let me just see the other point, yeah, this is point 3, point 4, point 5, and back to point 1. And immediately the plate is created. Let me double click on the plate, see the thickness, let me reduce that thickness. And then if I were to see it like that, I can see it's been created in the middle over there. All I need to do is just select it, press Ctrl W twice, and I have it exactly where I want. Now, if you notice, this plate is on the web of the secondary, and it's also going and hitting the exact points which it needs to hit as far as the main member is concerned. Now, obviously, there's a clash over here, and I can remove that clash by using my flange notch command over here. I can do a cut manually as well, but I can do it easily like this. I just select the bottom flange and I get a cut. And then I can increase the size of the cut, for example, over here by entering this size to be something like 150. And it's okay, now I've got the right length. But this side of the cut is not appropriate. So what do I need to do? I need to check the size of the beam, and the width of the flange is 150 and the web thickness is 7.1. So I need to half of the width is 75. So I need to remove half of 7.1 from 75, which is about 3.55. So it turns out to be 71.45, I think. So what I need to do is just enter that number over here, 71.45. And now we have a perfect smooth cut at that point. Now we have the plate ready. It's hitting exactly where I wanted it to hit. At this point, at this point, at this point, and over there as well. And let me go back to the plane, the view I had created at the web. And my bolt points, my work plane is over here, and I can immediately create my bolts. Now, where do I want my bolts to be? Over here. What points do I need? I need my origin, maybe somewhere in the center of these two. So let me put some dividing points between these two. Now, once my points are ready to create the bolt, I just need to go to my bolt command over here. Select the fin plate, which I've just created. Select the secondary member, right click to tell the program that there's no other material which I want to select, and then basically select the origin and the X direction. Now, two bolts are created by default because those are the default settings right now, but I can double click on that. I can go and change my diameter to something smaller. And then I can go to the positions tab and change the Y dimensions to -20 and 40. -20 will be from this origin, go -20 for the first bolt, and then go, this is the absolute coordinate, and then go a relative distance of 40 from there. So this is the second Y coordinate. And as far as the X coordinates are concerned, there are 0, 60, 60. So I want one row of bolts over at 0 level, one at 60, and another 60 from there. So if I press apply, I'll immediately get my bolts. Let me press OK. Go back to my 3D view over here. Go in there, and I can see that my connection is ready. It was a pretty complicated connection. The approaching beam was coming at an angle, and it wasn't 90 degrees, and it was also lifted and rotated and all that. So this plate was the most difficult part. But what we did was we used the point, the line plane intersection commands extensively, because creating these sets of points were easy. All we needed to go was just go to the web of the secondary and create these points. But point number 4 and 5 and point number 1 were tricky, and for them, what we did was we used the line plane intersection command to get point number 1, in which case we used the plane of the main and this line. But for point number 4 and 5, we use the plane of the web and these two lines to create the points. And then we just created the plate around them. and it was as simple as that. Then creating the bolts was pretty easy as well. So as you can see, if we needed a connection like this, we could just do that in a few minutes, as long as we can imagine what we needed to do in our minds. We have the commands to actually do the job.